We're going to go ahead and take a look at the behavior of gases. More specifically, we're going to look at Boyle's law. Boyle's law states that in a confined system, when the volume in that system decreases, the pressure inside the system increases. So it's an inverse relationship between volume and pressure. If you were to increase the volume, the pressure is going to go the opposite way. It will decrease. A good example of this is a balloon. If I was to blow up a balloon, tie it off so it's sealed, so there is our system. If I was to squeeze that balloon, thus making the volume smaller, the pressure is going to go the inverse relationship. So if the volume is going down, the pressure is going up. If you were to release that balloon once you've squeezed it, that volume is going to get bigger and the pressure inside is going to go down. To show this using a gas pressure sensor is what we're going to do today. So make sure before you look at this lab that you review the behavior of gas laws in your lab manual, and then there's a few analysis questions to answer after that. So for today, we're going to use our gas pressure sensor, which is right here, and we're going to use a syringe that will close up and attach to the sensor here, and then we will change the volume inside. We're either going to increase the volume or decrease the volume. And again, Boyle's law states that there's an inverse relationship between the two. So if one goes down, the other goes up. And hopefully we'll see that using our sensor today. So let me rotate the computer here so you can see the sensor and the readings that we have right here. So right now, I'm going to go ahead and connect this syringe to 10. It's on 10 now. As you can kind of see, the volume inside of here is 10, and our standard base is around 100 kilopascals, and right now it is at 99.76. And again, that is when we are at a volume of 10 on here. So I'm going to decrease the volume in the syringe all the way down to 4, all the way down to here. And we're going to see what happens when the volume decreases. We should have an increase in pressure there. So let me go ahead and do that. I want to kind of squeeze this down, and you can kind of see the volume is going down and the pressure is going up. So right now we're at 4 in volume, and our pressure is at 209, we'll say 0.5. It's going to continue to fluctuate as it goes there. All right, so 209.5 was at 4 milliliters in volume in here. So let me go to 5 now, see what our volume is going to be here at 5, and our pressure, 191. So again, you should be recording these in your lab manual. Let me go to 6. So I'm going to increase the volume, thus making the pressure go a little bit less. So 163 at 6. I was at 6. At 7, we're at 140. Increasing it to 8, 125, and I'm rounding on the LabQuest on the sensor. At 9, 122. Again, we'll go back to 10 and get one final measurement at 10. And we're at 100. And I'm going to start increasing. 11. Our number is 93. 12. 85. 13. Again, that's the volume I'm talking about. 13. 70, 79. Again, I'm rounding on the screen. 14 volume, 73. 15 volume, 69. 16 volume, 65. 17. 61. 18 volume, 57. 19 volume, 55. And 20.
50.
Okay, so those are your numbers for the Boyle's law, gas laws. There are 3 analysis questions that follow in that lab. So you're going to want to look at your data, make your correlations with how the volume and pressure inversely change from one another, and then you're going to make a line graph. Now, since there are 2 variables here, volume and pressure, and they're both changing, they're interdependent upon each other, it doesn't matter which axis you put, the X or Y, that you put either variable. So you can put the volume on one and the pressure on the other, or vice versa. If you have any questions, of course, let me know. Good luck.